Good morning, friends. We are starting with miscellaneous on chapter number 1. We don't have binary operations as a part of our CBSE curriculum. So that exercise we have not taken. So we are going for miscellaneous exam exercise. The questions are similar what we have done till now. So let us see question number 1. So in question number 1 we are given a function fx is equal to 10x plus 7 and it is defined from real number to real number. Then we have to find the function g such that gof is equal to fog is equal to identity element. So it means we have to find out g, that is inverse of f. So for inverse of we have to find out, first we have to check whether the function is 1 1. Again we have to let fx1 is equal to fx2. So that means 10x1 plus 7 is equal to 10x2 plus 7. 7 will get cancelled 7. 10 will cancel 10. We are left with x1 is equal to x2. Therefore it is 1 1. We are having only one value. x1 is equal to x2. Second, let us check for onto. So what do we do for onto? We have to write x in terms of y. So we are given y is equal to 10x plus 7. It implies 10x is equal to y minus 7, which implies x is equal to y minus 7 upon 10. Correct? This is basically the function that we are looking for, gy. And this is gy. This is equal to f inverse of y or f inverse of x. You can have anything. Okay. So for onto we can see for every y we'll be finding a x. What is y? Y is the range. So we can say since y is equal to its codomain real numbers, so that means this function is onto. Function is onto. Now we have to look for gy, gof and fog. So first case g of f, it is simply g of fx. So pass input as fx, and what is fx? Fx is equal to 10x plus 7. So g of y is given as y minus 7 upon 10. G of fx, fx is equal to 10 plus 7, right? So gy is equal to y minus 7 upon 10. So it will lead to 10x plus 7 minus 7 upon 10. 7 will cancel 7, 10 will cancel 10. We are left with x. So we have got the identity element. Similarly for fog, it is equal to f will take input as gy, right? So f will take input as gy, and what is gy? Gy is y minus 7 upon 2. So our output will be 10 into gy plus 7. So it is equal to 10 into gy. What is gy? Y minus 7 upon 10 plus 7. 10 will cancel 10. 7 will cancel 7. We are left with y. So we have got the anti element. So that means g is equal to f inverse and f is equal to g inverse. Correct? So this is a solution to question number 1. Let us see question number 2. Let a function be defined from whole numbers to whole numbers such that fn is equal to n plus 1, and if fn is equal to n minus 1 if n is odd, and fn is equal to n plus 1 if n is even. So that function is invertible. Okay. If it is invertible, we have to find out inverse. So in this case, let us write the definition of function over here. If the input is n, so the value is n minus 1, the value is n plus 1, it is n minus 1 if n is odd, and this is the value if n is even. Okay. So first case we'll check whether the function is 1 1. So we'll take the cases. So first case is when both the values are even. That means we are having two values x1 x2. Let they be even. They are element of even numbers, right? 2 are. Okay. Now again let fx1 is equal to fx2. So when n is even, it is equal to n plus 1. So that means x1 plus 1 is equal to x2 plus 1. 1 will get cancelled. We are left with x1 is equal to x2. 1 1. Case 2 will take when both the values are odd. That means x1, x2 are odd values, 2r plus 1 form. So let fx1 is equal to fx2. It implies x1 minus 1 is equal to x2 minus 1, which implies x1 is equal to x2, again 1 1. Case 3 will take. Case 3 is when one is even and another is odd, right? Let us take x1 is even and x2 is odd, or vice versa. X1 is odd, x2 is, let us say, even. Both will give the same output, right? Similar output. So again let fx1 is equal to fx2. It implies x1 minus 1 is equal to x2 plus 1. So x1 minus x2 is equal to what you have got, 2. But this is not possible. Since one value is odd, another is even, the result should always be odd. So this is discarded. Similarly, we'll be having case 4. In case 4, if you can take x1 as even and x2 as odd, so again you'll be finding the even value, even integer, right? But again that will be discarded. So for only 2 cases when both are even or both are odd, we'll be finding the solution is 1 1. Now we have to check for onto. Onto means domain should be equal to range, correct? So let us see how do we do it. So we can do it like this, that we are having a mapping diagram. We can show it with the help of mapping diagram. We are having this as x, this set as capital Y. We are showing whether it is onto. So it is 0, 1, 2, 3, 4, 5, 6 and so on. 0, 1, 2, 3, 4, 5, 6 and so on. Right? This is the function that is defined. We have to find out this function g, that is the inverse of f, if it is onto. So let us see. So if the function is even, it is n plus 1. So 0 will be mapped to 1, 2 will be mapped to 3, 4 will be mapped to 5 and so on. And 1 will be mapped to 0, because if n is odd, it will be n minus 1. 3 will be mapped to 2, 5 will be mapped to 4, right? And so on. So similarly we can see we are having a mapping for, we are having a y for every x. So that means y is equal to capital Y, right? Complete set will be exhausted. So y is equal to capital Y, that means it is equal to codomain, the function is onto. Now we have to find, we have to define this function g. So it is very easy. How can you define it? Because we have seen that g is equal to f inverse. It will be invertible, correct? So you can see from this set, because now for this g, it will be input and it will be output. For g, it will be domain, it will be range. So we can define a function like this, gn. So if we are having this as the input, 0 as the input, 0 is even. So if n is even, what is the output? It is equal to 1, right? So that means it is n plus 1. And when n is odd, when it is 1, right? What is the output? It is 0. So that means it is n minus 1. So this is the function that we are talking of and we have defined it. So this is the result. Okay. Now let us come to question number 3. if a function from R to R is defined as fx is equal to x cube minus 3x plus 2, find f of fx. So this is relatively easy, correct? It is x square minus 3x plus 2. We have to find out f of fx. So let us do it. Fx is equal to, it is question number 3. Fx is equal to x square minus 3x plus 2. So f will be taking fx as the input. So it will be equal to x square. Okay. Fx is equal to x square minus 3x plus 2. So f of fx is equal to fx whole square minus 3 fx plus 2. Fx whole square means that we have to square this complete term. So x square minus 3x plus 2 whole square minus 3 times fx, that means x square minus 3x plus 2 plus 2. Open this, you know the identity for a plus b plus c whole square, minus this plus this, and you'll be getting the expression, and that will be the result, right? And the result will be, do it yourself. Correct? It is easy. Give some time to this question. Okay. Coming to question number 4. Show that